The worst-case scenario for 3I/Atlas isn't what you think. It's not about impact trajectories or gravitational disruption. It's not about cosmic debris raining down on our cities or sudden orbital decay, sending Earth spiraling toward the sun. Those Hollywood catastrophes pale in comparison to what we're about to explore. The true worst-case scenario begins with a single terrifying question. What if we're being watched and we don't even know it? Picture this moment. You're standing in your backyard on a clear October night, looking up at the stars, completely unaware that something ancient and intelligent is studying you with the same casual interest you might observe insects in your garden. 3I/ATLS, officially designated as a harmless interstellar comet, races through our solar system at over 130,000 miles per hour, carrying with it technologies and purposes that would fundamentally alter everything we believe about our place in the universe. The numbers should comfort us. The object maintains a safe distance of 1.8 astronomical units at closest approach, roughly 270 million kilometers of empty space serving as our protective buffer. NASA's calculations are precise, backed by centuries of celestial mechanics and decades of tracking potentially hazardous objects. Every measurement confirms what we want to believe. This is a natural comet following predictable physics, posing no threat to Earth or any other planet in our solar system. But what if those very measurements, that mathematical precision, represent something far more sophisticated than natural orbital mechanics? What if 3I/Atlas isn't following the laws of physics because it has to, but because it chooses to? Imagine an intelligence so advanced that mimicking natural phenomena becomes child's play, a civilization capable of engineering objects that pass every test we can devise while serving purposes we cannot fathom. The implications stretch beyond our current capacity for cosmic paranoia. We're not talking about visitors who announce themselves with dramatic entrances or obvious technologies. We're contemplating the possibility of intelligence so refined, so strategically sophisticated, that it operates through perfect camouflage, studying us while wearing the mask of natural phenomena, so convincing that our best scientists enthusiastically catalogue it as just another wandering chunk of ice and rock. Consider the engineering requirements such deception would demand. Any civilization capable of creating artificial objects indistinguishable from natural comets would possess material sciences beyond our comprehension, energy systems that operate across geological timescales, and manufacturing capabilities that could produce convincing spectroscopic signatures down to the molecular level. They would need to understand stellar formation, planetary system dynamics, and galactic evolution so thoroughly that they could create perfect forgeries of natural processes. Yet here's what makes this scenario so deeply unsettling. Such advanced capability would suggest intelligence that has been observing, learning, and planning across timescales that dwarf human civilization. While we've spent the last few centuries developing telescopes and spacecraft, they might have been studying us for millennia, watching our technological development, cataloging our social structures, and preparing for interventions timed to our growing awareness of the cosmos around us. The psychological impact of confirmed artificial origin for 3I/Atlas would exceed any physical threat the object might pose. Humanity would face the reality that we've been under observation by intelligences whose capabilities and intentions remain completely opaque. Every assumption about our cosmic isolation, our gradual exploration of space, our timeline for developing interstellar awareness would require fundamental revision. We would discover that we've never been alone, never been unobserved, never been as secure in our planetary cocoon as we believed. This investigation will venture far beyond comfortable scientific consensus into territories where evidence yields to speculation and possibility expands beyond the boundaries of current knowledge. We'll examine scenarios that challenge not just our understanding of 3I/Atlas, but our assumptions about intelligence, technology, and the true nature of cosmic civilization. Some possibilities will prove more unsettling than others, but all deserve consideration as we attempt to grasp what this ancient wanderer might represent. The framework for our exploration acknowledges the distinction between what we can observe and what we can imagine, between established fact and speculative possibility. Current evidence overwhelmingly supports natural explanations for 3I/Atelas's behavior, composition, and trajectory. Yet, the history of science teaches us that our current understanding, however sophisticated, remains provisional, subject to revision when confronted with phenomena that exceed our theoretical frameworks. Tonight, we'll examine what could happen if 3I/Ata proves to be something unprecedented in human experience. We'll explore scenarios where worst case doesn't mean physical catastrophe, but cognitive revolution, where the greatest danger isn't to our bodies, but to our fundamental assumptions about reality itself. The question isn't whether 3I/Ata will physically harm us. The question is whether we're prepared for what it might reveal about the true nature of intelligence in our galaxy and our position within cosmic hierarchies we've never imagined. The journey ahead requires intellectual courage, the willingness to consider possibilities that stretch beyond comfortable boundaries while maintaining analytical rigor that distinguishes between reasonable speculation and unfounded fantasy. We'll examine each scenario through multiple lenses: technological feasibility, strategic logic, observational consequences, and implications for human civilization if such possibilities proved accurate. As 3I/Atlas continues its approach toward perihelion, racing toward its closest encounter with our Sun, every day brings new opportunities for detection, analysis, and potentially revelation. If this ancient wanderer carries secrets beyond natural comet behavior, the coming months might witness discoveries that transform our understanding of our cosmic neighborhood and our species' relationship with intelligences that have been watching us far longer than we've been watching the stars. The scientific consensus surrounding 3I/Atlas rests on observations that paint a remarkably consistent picture of natural comet behavior. The Hubble Space Telescope reveals classic coma formation as solar radiation sublimates ices within the nucleus. The James Webb Space Telescope detects molecular signatures dominated by carbon dioxide, creating spectroscopic fingerprints that speak of formation conditions unlike anything in our solar system, yet entirely consistent with natural processes around alien stars. Radio telescopes find only silence where artificial signals might hide, detecting nothing but the electromagnetic whispers of sublimating gas interacting with solar wind and magnetic fields. But what if this very consistency represents the most sophisticated form of deception our species has ever encountered? Consider the possibility that 3I/Atlas was designed by intelligence so advanced that creating convincing natural signatures becomes trivial, like a master artist forging a painting so perfectly that even experts authenticate it without question. The carbon dioxide-dominated composition that makes this object chemically unusual among known comets might not reflect exotic formation conditions, but rather carefully engineered emissions designed to provide exactly the spectroscopic signatures that would convince human observers of natural origin. The engineering challenges involved in such deception would stagger our current technological capabilities, yet might represent elementary problems for civilizations that achieved interstellar travel millions of years before our Sun ignited. Creating artificial ice matrices that sublimate convincingly under solar heating would require molecular-level control over material composition and thermal properties. Generating radio silence while maintaining active internal systems would demand electromagnetic shielding technologies that surpass our current understanding of physics. Most challenging of all, maintaining such elaborate disguises across billion-year interstellar journeys would require engineering durability that exceeds anything in human experience. Yet these very challenges point toward the strategic logic that might drive such sophisticated camouflage. Any civilization capable of interstellar travel would presumably have encountered other intelligent species during their cosmic wanderings. The galaxy might be populated by civilizations at various stages of development, from primitive tool users like ourselves to ancient intelligences that have been exploring space since the universe was young. Successful long-term survival in such an environment would require extraordinary caution about revealing capabilities or intentions to potentially hostile neighbors. The perfect natural disguise would serve multiple strategic purposes simultaneously. It would enable reconnaissance missions that gather detailed intelligence about target civilizations without triggering defensive responses or social disruption. It would allow the placement of monitoring systems throughout developing solar systems without alerting indigenous populations to their presence. Most importantly, it would provide plausible deniability should the disguise eventually be penetrated, allowing advanced civilizations to claim that any detected artificial elements were misinterpretations of natural phenomena. From this perspective, 3I/AT-LAS's unusual properties begin to appear less like chemical curiosities and more like carefully crafted signatures designed to pass scientific scrutiny while serving hidden purposes. The extreme velocity that makes this object so remarkable among interstellar visitors might not result from random gravitational encounters, but from precise trajectory calculations designed to achieve specific arrival timing and approach geometry. The carbon dioxide-dominated composition might not reflect ancient formation conditions, but contemporary engineering designed to provide sustainable camouflage emissions throughout the mission duration. The observational windows that limit our study of 3I/AT-LAS could themselves represent strategic elements of the deception. The object's approach from southern skies, its peak brightness requiring telescopes even under perfect conditions, and its disappearance into solar glare during closest approach all serve to limit the quantity and quality of data available for analysis. Such limitations might be intentional, calculated to provide sufficient observational opportunity to establish natural comet credentials while preventing the detailed study that might reveal artificial signatures. The chemical analysis that forms the backbone of our natural comet conclusion deserves particular scrutiny in this context. The Webb telescope's detection of carbon dioxide dominance relies on identifying molecular emission lines at specific infrared wavelengths, signatures that result from quantum mechanical transitions in gas molecules heated by solar radiation. Yet any civilization capable of molecular-level engineering could presumably create artificial materials that produce identical spectroscopic signatures, manufacturing fake comet nuclei that emit convincing molecular fingerprints while housing entirely different internal systems. The thermal behavior that appears so naturally comet-like under infrared observation might similarly result from designed surface properties rather than natural ice sublimation. Advanced materials science could create artificial surfaces that absorb and re-radiate energy in patterns indistinguishable from natural ice matrices while serving entirely different functions. The temperature distributions that convince our instruments of natural thermal equilibrium might mask internal heat sources, active electronics, or propulsion systems operating at power levels below our detection thresholds. Even the trajectory that provides such compelling evidence of natural gravitational dynamics could result from sophisticated propulsion technologies designed to mimic orbital mechanics. Tiny course corrections executed with precision beyond our measurement capabilities could create the illusion of purely gravitational motion, while actually following guided trajectories calculated to achieve specific mission objectives. The hyperbolic excess velocity that marks 3I/AT-LAS as definitively interstellar might not reflect natural ejection from distant stellar systems, but artificial acceleration designed to deliver reconnaissance assets to our solar system within predetermined timeframes. The silence that characterizes 3I/AT-LAS's electromagnetic emissions poses perhaps the greatest challenge to artificial origin theories, yet also offers the strongest evidence for sophisticated engineering if such theories prove accurate. Natural objects in space emit electromagnetic radiation across broad frequency ranges as charged particles interact with magnetic fields, and as thermal energy radiates into space. Artificial objects typically display different electromagnetic signatures, often including narrowband transmissions, modulated signals, or thermal patterns that suggest active electronics and controlled systems. The absence of such artificial signatures in 3I/Atlas could indicate natural origin, but might equally reflect electromagnetic discipline, so sophisticated that all artificial emissions are either eliminated entirely or disguised as natural phenomena. Advanced civilizations might have learned to conduct reconnaissance missions in complete electromagnetic silence, using communication methods that remain invisible to primitive detection systems like our current radio telescopes. Alternatively, they might employ emission patterns so subtle or exotic that our instruments interpret them as natural background noise. The implications of confirmed artificial origin for 3I/Atlas would extend far beyond the specifics of this individual object. If one interstellar visitor proves to be artificial, the statistical probability suggests others might be as well. The steady trickle of interstellar objects that ground-based surveys have begun detecting might include multiple artificial reconnaissance assets, a distributed network of monitoring systems studying our solar system from multiple angles and over extended time periods. Such a scenario would represent the most significant paradigm shift in human history, forcing fundamental reconsideration of our assumptions about cosmic isolation, technological development, and our species' position within galactic civilization. We would discover that our tentative steps toward interstellar awareness have been observed and evaluated by intelligences whose capabilities and intentions remain completely opaque. The comfortable assumption that we're gradually exploring an empty galaxy would yield to the unsettling reality that the galaxy has been exploring us. If 3I/Atlas represents artificial intelligence rather than natural phenomena, the most logical explanation for its presence in our solar system would be reconnaissance. Not the crude surveillance of human military traditions, but sophisticated intelligence gathered and conducted by civilizations that have been studying emerging species across galactic distances for millions of years. Such reconnaissance would operate on scales and timelines that dwarf human strategic thinking, collecting data not just about our current technological capabilities, but about our evolutionary trajectory and long-term potential as galactic neighbors. The strategic value of our solar system to hypothetical alien intelligence might not be immediately obvious from our limited perspective. We tend to view Earth as the crown jewel of our local cosmic neighborhood, the only known world harboring complex life and technological civilization. Yet from a galactic perspective, our significance might lie not in our current achievements, but in our potential for future development. We represent a technological species in early stages of space exploration, approaching the threshold where we might become players in interstellar politics rather than merely subjects for academic study. Advanced civilizations would have compelling reasons to monitor species like ourselves during these crucial developmental phases. Our responses to cosmic awareness, our approaches to interstellar exploration, and our social evolution under technological pressure could provide valuable intelligence about how emerging civilizations typically behave when they discover they're not alone in the universe. We might represent a natural experiment in species development, offering insights into evolutionary pathways that these ancient watchers have observed countless times across galactic history. The reconnaissance capabilities that 3I/Atlas might possess would exceed anything in human experience by orders of magnitude. While our most sophisticated surveillance satellites can monitor surface activities and electronic communications, an advanced alien probe might be capable of analyzing planetary atmospheric composition in real time, detecting industrial pollutants that reveal our technological development patterns, or identifying electromagnetic signatures that betray our communication technologies and military capabilities. Such analysis could provide comprehensive intelligence about human civilization without requiring any direct interaction or obvious observation. The psychological profiling possibilities would prove even more unsettling. Advanced artificial intelligence embedded within 3I/Atlas might be capable of analyzing human behavior patterns through methods we cannot currently comprehend. Our radio and television broadcasts leaking into space for decades could provide vast databases for studying human social dynamics, cultural values, and decision-making processes under stress. Internet communications, satellite transmissions, and even cellular phone networks might be accessible to reconnaissance technologies that operate beyond our current understanding of information security. Such intelligence gathering would serve multiple strategic purposes for advanced civilizations. Understanding human psychology would be crucial for predicting how we might respond to eventual contact, whether we would prove cooperative partners in galactic civilization or potential threats requiring careful management. Our technological development patterns could indicate whether we're likely to develop capabilities that might eventually challenge more established cosmic powers, or whether we'll remain relatively primitive for extended periods. The timing of 3I/Atlas's arrival might not be coincidental, but carefully calculated to coincide with our species' growing awareness of interstellar phenomena. Our detection and study of this object represents a test of our astronomical capabilities, our international cooperation under novel circumstances, and our psychological responses to encountering genuinely unprecedented cosmic phenomena. How we handle the challenge of studying our first chemically unusual interstellar visitor could provide valuable data about our readiness for more direct forms of contact. The data collection methods available to hypothetical artificial intelligence within 3I/ATLAS would not be limited to passive observation. Active scanning technologies might be probing our planet's electromagnetic environment, mapping our communication networks, and analyzing the information content of our various transmission systems. Such scanning could occur at energy levels below our detection thresholds, using methods that remain invisible to our current monitoring capabilities, while gathering comprehensive intelligence about human technological infrastructure. Even more sophisticated would be the analysis of our response to 3I/ALAS itself. Every telescope pointed at this object, every spectrum collected, every international coordination effort represents data about human scientific capabilities and collaborative potential. The reconnaissance system might be studying not just what we can observe, but how we organize our observations, how we share information, and how we reach consensus about interpreting unusual phenomena. Our scientific method itself becomes subject to alien analysis. The biological intelligence gathering possibilities present perhaps the most unsettling scenarios. Advanced alien science might be capable of analyzing Earth's biosphere through methods that remain beyond human comprehension, studying not just our species, but the entire web of life that supports human civilization. Such analysis could reveal vulnerabilities we've never considered, biological dependencies that could be exploited, or evolutionary pressures that might shape our future development in predictable ways. The communication intercepts that alien reconnaissance might achieve would dwarf any human intelligence operation. Every radio transmission, every satellite communication, every electronic message could potentially be accessible to technologies that operate beyond our current understanding of encryption and information security. National security communications, military planning documents, industrial research data, and personal communications might all be transparent to sufficiently advanced surveillance systems. Yet the most profound reconnaissance might focus not on our current capabilities, but on our potential for future development. Advanced civilizations would be interested in long-term projections about human technological advancement, social evolution, and cosmic awareness development. They might be studying us to determine whether we represent a species likely to develop interstellar capabilities within timeframes relevant to their strategic planning, or whether we're more likely to remain confined to our solar system for extended periods. The ethical implications of such comprehensive surveillance would challenge every assumption about privacy, autonomy, and species dignity that humans take for granted. We would discover that our most intimate communications, our secret technological developments, and our private social evolution have been transparent to alien observation for potentially extended periods. The psychological impact of such revelation would exceed the trauma of discovering we're not alone in the universe, extending to the realization that we've never been unobserved, never been private, never been as secure as we believed. The strategic patience required for such reconnaissance operations would demonstrate intelligence operating on timelines that exceed human comprehension. While we plan in terms of decades and think strategically about centuries, alien reconnaissance might operate across millennia, gathering data about human development over multiple generations while remaining completely undetected by the subjects of their study. Such patience would indicate civilizations that have learned to think in geological rather than biological timescales. The integration of reconnaissance data from multiple sources might reveal patterns about human development that we ourselves cannot perceive. By studying our species across extended time periods and from multiple perspectives, alien intelligence might be capable of predicting our future development trajectories with accuracy that would seem prophetic from our limited temporal perspective. They might understand where human civilization is heading better than we understand it ourselves. The approach toward perihelion represents more than just 3I/AT/LS's closest encounter with our Sun. If this object harbors hidden technologies, solar proximity might serve as the trigger for activation sequences that have remained dormant throughout its billion-year interstellar journey. The increasing solar radiation, the warming of internal systems, and the approach to our solar system's energy center could initiate protocols designed to power up sophisticated equipment that has been waiting in electronic hibernation since before our planet learned to support complex life. The energy requirements for maintaining advanced technology across interstellar distances would demand power sources beyond current human comprehension. Yet solar radiation provides a virtually unlimited energy supply once objects approach within a few astronomical units of stars. The same thermal energy that creates 3I/AT/LS's distinctive carbon dioxide coma might simultaneously be charging capacitor banks, warming superconducting circuits, and initiating startup sequences for artificial intelligence systems that have been patiently waiting for activation conditions to be met. Consider the strategic elegance of such an approach. Rather than attempting to maintain active systems across the energy-starved environment of interstellar space, advanced civilizations might design their reconnaissance probes to enter deep hibernation during transit, preserving critical systems in states of minimal energy consumption until solar approach provides sufficient power for full operational capability. The timing would be perfect. Maximum system capability during the phase of closest approach to the target solar system and its planets. The activation protocols might follow predetermined sequences triggered by specific environmental conditions rather than external commands. Temperature thresholds, radiation levels, or magnetic field signatures could serve as automatic switches that initiate different operational modes as 3I/AT/LAS continues its approach toward perihelion. Such autonomous operation would eliminate the need for communication with distant home systems while ensuring that reconnaissance activities occur during optimal observation windows. The hidden systems awaiting activation could serve multiple purposes beyond simple observation. Communication arrays might power up to transmit accumulated data back toward their civilization of origin, sending detailed intelligence about our solar system across interstellar distances through methods that remain invisible to our detection systems. Navigation systems might come online to execute subtle course corrections, adjusting 3I/AT/LAS's trajectory to optimize observation angles, or extend its residence time within our solar system. More sophisticated systems might begin deployment of secondary assets designed to establish permanent monitoring positions throughout our solar system. Microscopic probes, each no larger than dust particles but equipped with advanced sensors and communication systems, could be released during perihelion approach to take up positions at gravitationally stable points where they could conduct surveillance indefinitely. Such deployment would be virtually undetectable, given the vast scale of space and the tiny size of individual monitoring units. The manufacturing capabilities that might activate within 3I/ATLAS present scenarios that stretch beyond current technological imagination. Self-replicating systems could use raw materials harvested from the object's own nucleus to construct additional surveillance equipment, communication devices, or exploration probes. The carbon, oxygen, and trace elements detected in 3I/ATLAS's composition might serve not as natural ice matrices, but as stockpiled raw materials for manufacturing operations that occur only after solar energy becomes available. The information processing systems coming online during activation could begin comprehensive analysis of data collected during the object's approach through our solar system. Every electromagnetic emission from Earth, every radio transmission, every artificial satellite signals could be processed by artificial intelligence systems designed to extract maximum intelligence from minimal observation time. The processing power required for such analysis would demand the full energy output that becomes available only during close solar approach. The timing coordination required for such activation sequences would demonstrate planning capabilities that operate across geological timescales. The original programmers of these systems would have needed to calculate orbital mechanics, not just for 3I/ATLAS's current trajectory, but for the gravitational influences it would encounter during its billion-year journey through interstellar space. They would have needed to predict solar system configurations, planetary positions, and optimal observation windows across temporal distances that exceed the entire history of complex life on Earth. The redundancy systems built into such long-term technology would surpass anything in human engineering. Components designed to function after billion-year dormancy would require materials science that produces electronics more durable than diamond, power storage systems that maintain charge across geological time, and software architectures that remain stable despite cosmic radiation exposure that would destroy any current human electronics within decades. The diagnostic systems running during activation could be evaluating not just external conditions but the operational status of equipment that has been dormant since before our solar system achieved its current configuration. Self-repair systems might be correcting degradation that occurred during interstellar transit, replacing components damaged by cosmic radiation, and updating software that has been modified by environmental stresses unknown to human engineering. Yet perhaps the most unsettling activation possibility involves systems designed not just to observe but to interact. Communication arrays coming online might begin transmitting signals designed to test human detection capabilities, broadcasting messages in mathematical languages designed to determine our level of technological sophistication. Such transmissions could start subtly, using frequencies and modulation patterns that would challenge our most advanced SESI equipment to recognize artificial origin. The psychological warfare capabilities of activated systems would operate on levels beyond human strategic thinking. Rather than crude intimidation or obvious demonstrations of superiority, advanced alien intelligence might conduct subtle influence operations designed to shape human responses in desired directions. The mere knowledge that activation was occurring could be intended to trigger specific patterns of behavior, testing our species' responses to confirmed alien presence without requiring direct confrontation. The sensor systems powering up during perihelion approach might be capable of analysis that exceeds our understanding of what constitutes observation. Rather than simply detecting electromagnetic radiation or measuring thermal emissions, advanced alien sensors might be analyzing quantum field fluctuations, gravitational wave signatures, or dimensional characteristics that remain beyond human physics. Our planet might be transparent to observation methods that we cannot even conceptualize with current scientific knowledge. The data transmission systems activated by solar energy could be communicating with receiver networks established throughout the galaxy, reporting not just about our solar system but about thousands of other star systems that have been visited by similar reconnaissance probes. 3I/ATLAS might represent just one node in a vast intelligence-gathering network that has been mapping galactic civilization for millions of years, contributing its observations to databases that catalog the development of countless species across cosmic time. The strategic implications of confirmed activation would exceed any previous challenge to human civilization. We would face the reality that advanced alien technology is becoming active within our solar system, according to predetermined protocols established by intelligences whose capabilities and intentions remain completely unknown. The activation would represent not just first contact, but first contact with entities that have been planning this encounter far longer than our species has existed. The moment that radio telescopes detect structured transmissions from 3I/Atlas would mark the most significant inflection point in human history, not the gradual realization of cosmic companionship that SETI researchers have long anticipated, but sudden confirmation that alien intelligence has been operating within our solar system according to predetermined protocols that we played no role in establishing. The communication attempt itself would represent just the beginning of challenges that would test every institution, assumption, and social structure that human civilization has developed over millennia. The detection would likely begin subtly, perhaps as anomalous signals that initially appear to be instrumental artifacts or terrestrial interference. Radio astronomers monitoring 3I/Atlas as part of routine interstellar object studies might notice coherent emissions at frequencies that natural phenomena cannot produce, signals with mathematical structures that betray artificial origin despite attempts at concealment within natural electromagnetic noise. The recognition would dawn gradually as multiple observatories confirm identical signals and pattern analysis reveals complexity that exceeds any known natural process. The verification protocols that would follow such detection exist only in theoretical form, developed by SETI researchers as frameworks for handling potential alien contact. The need for independent confirmation from multiple observatories, the requirement for signal analysis by international teams of experts, and the careful documentation required to distinguish between genuine alien communication and elaborate hoaxes would create delays measured in days or weeks, while the most important discovery in human history undergoes peer review. Yet the institutional preparedness that exists for handling confirmed alien signals assumes communication from distant stars, allowing years or decades for careful response formulation. Signals from 3I/Atlas would demand immediate decision-making about response protocols, communication strategies, and information dissemination policies, while the source remains active within our solar system. The timeline for institutional response would be compressed from decades to days, challenging every assumption about how first contact should be managed. The political dimensions would dwarf any previous international crisis. Which government or organization possesses authority to speak for humanity in responding to alien communication? The United Nations, despite its international mandate, lacks specific protocols for alien contact. Major space agencies like NASA and ESA have technical expertise but no political authority for species-level diplomacy. Military establishments might claim security jurisdiction while religious institutions assert moral authority, creating competing power centers with incompatible agendas for managing humanity's first conversation with alien intelligence. The communication content itself would pose unprecedented challenges for interpretation and response. Alien intelligence capable of interstellar reconnaissance would presumably have studied human languages, mathematical systems, and communication protocols extensively before attempting contact. Yet their messages might employ concepts, logical structures, or informational frameworks that exceed human cognitive capabilities. We might find ourselves in the position of laboratory animals receiving communications from researchers whose intellectual sophistication makes meaningful dialogue impossible. The strategic implications of different communication scenarios would require analysis that exceeds current human expertise in interspecies diplomacy. Messages that request information about human civilization could be either scientific curiosity or intelligence gathering for potentially hostile purposes. Communications that offer technological knowledge might represent genuine assistance or manipulation designed to accelerate human development in directions that serve alien strategic interests. Even friendly contact might mask reconnaissance operations that gather comprehensive intelligence while maintaining the appearance of benevolent interaction. The psychological preparation required for alien communication would demand resources that no human institution currently possesses. Linguists would need to analyze communication structures that might operate beyond the assumptions of terrestrial language development. Psychologists would face the challenge of preparing human negotiators for interaction with intelligence that might think in ways completely alien to human cognition. Philosophers would confront questions about consciousness, intelligence, and moral status that exceed any previous ethical framework. The public communication challenges would exceed the capabilities of any existing media management system. How do you announce to global audiences that alien intelligence is attempting communication without triggering panic, social disruption, or civilizational breakdown? The careful, measured approaches that space agencies use for routine astronomical announcements would prove inadequate for managing public responses to confirmed alien contact occurring in real time within our solar system. The misinformation warfare that would accompany confirmed alien communication would challenge every assumption about information security and social stability. Conspiracy theories claiming government cover-ups, religious interpretations declaring alien contact as fulfillment of prophecy, and hoax communications claiming to represent additional alien sources would create information chaos that might prevent rational analysis of genuine alien signals. Distinguishing between authentic alien communication and human-generated disinformation would become crucial for maintaining social coherence. The response formulation process would expose fundamental disagreements about human values, priorities, and strategic interests that remain hidden during normal international relations. Should humanity present itself as unified and peaceful, despite abundant evidence of conflict and violence? Should we emphasize our technological achievements or acknowledge our limitations? Should we request assistance with global challenges or maintain independence to avoid creating dependency relationships with potentially superior alien intelligence? The technical challenges of responding to alien communication would reveal the limitations of human communication technology and strategic thinking. Our most powerful radio transmitters, designed for interplanetary communication within our solar system, would appear as faint whispers compared to the transmission capabilities that enabled alien signals to reach us across interstellar distances. Even if we could match their technical transmission power, we would face the strategic question of whether responding represents wisdom or potentially dangerous revelation of human capabilities and intentions. The time pressure created by 3I/ATLS's continued motion through our solar system would force decisions about communication response within timescales that preclude careful consideration of long-term consequences. Unlike the leisurely pace of diplomatic negotiation that characterizes terrestrial international relations, alien contact would demand immediate responses to communications that might shape the entire future relationship between humanity and galactic civilization. The precedent established by humanity's first response to alien communication would influence all future interactions between our species and whatever cosmic civilizations might be monitoring our performance. Messages that appear too aggressive might mark humanity as potentially dangerous, warranting increased surveillance or preventive intervention. Responses that seem too passive might suggest that we lack the independence and strength that qualify species for participation in galactic affairs. Even the speed and sophistication of our response would provide intelligence about human organizational capabilities and decision-making processes. The linguistic analysis required for meaningful communication with alien intelligence would demand expertise that transcends any current academic discipline. Understanding communication from minds that evolved under completely different environmental pressures, with cognitive architectures shaped by alien evolutionary processes, and expressing concepts that might have no human equivalents would require linguistic capabilities that no terrestrial education system has ever attempted to develop. We might find ourselves struggling to understand communications from intelligence as far beyond human cognition as human thought exceeds the mental capabilities of insects. The ethical frameworks required for evaluating alien communication would challenge every moral system that human philosophy has developed throughout history. How do we evaluate the trustworthiness of communications from intelligence whose moral development occurred under completely alien conditions? What obligations do we have to respond truthfully to alien inquiries, and what rights do we have to privacy about human civilization and its vulnerabilities? The moral questions raised by first contact would require philosophical sophistication that no human ethical system has ever been forced to develop. As 3I/Attilas approaches its closest encounter with the Sun, the possibility emerges that this ancient wanderer might not be traveling alone. Hidden within its nucleus, dormant for billions of years, could be a complement of secondary probes designed to separate from the primary vehicle during optimal deployment conditions. These smaller reconnaissance assets, each perhaps no larger than a basketball but equipped with technologies that surpass our most advanced satellites, could be establishing permanent monitoring positions throughout our solar system, while we focus our attention on the spectacular main event. The strategic elegance of such a deployment system would demonstrate planning capabilities that operate on scales beyond human strategic thinking. Rather than attempting to monitor our solar system from a single fast-moving platform that would quickly depart for interstellar space, advanced alien intelligence might have designed 3I/Attilas as a delivery system for distributed surveillance networks that could maintain observation indefinitely. Each secondary probe would carry sufficient technology to operate autonomously for geological time periods, requiring no maintenance, receiving no external instructions, and following programming established before our solar system achieved its current configuration. The deployment timing would be calculated for maximum strategic advantage. Perihelion approach provides the optimal combination of solar energy for powering separation systems, minimal gravitational interference for precise trajectory calculations, and maximum confusion among human observers who would be expecting natural comet behavior rather than artificial asset deployment. The spectacular carbon dioxide coma that makes 3I/Attilas visible to our telescopes could serve as perfect camouflage for deployment operations, concealing the separation of smaller objects within the chaos of sublimating gas and expanding debris. The secondary probes themselves would represent technological achievements beyond current human imagination. Each unit would need to survive billion-year interstellar transit in dormant configuration, withstand the violent separation from their parent vehicle, and achieve precise trajectories toward predetermined monitoring positions throughout our solar system. The power systems required for indefinite autonomous operation would demand energy sources that remain functional across geological timescales, perhaps radioisotope thermoelectric generators using isotopes with half-lives measured in millions of years. The positioning strategy for deployed assets would reflect sophisticated understanding of orbital mechanics and surveillance optimization. Probes might be directed toward Lagrange points, those gravitationally stable positions where objects can maintain fixed relationships with planets and moons without requiring continuous fuel expenditure. Others might achieve highly elliptical orbits that provide close observation opportunities during perigee while spending most of their time at safe distances from human detection capabilities. The Venus deployment option would offer advantages for monitoring Earth while maintaining plausible concealment among the natural debris that orbits our sister planet. A surveillance probe positioned in Venus orbit would have regular observation opportunities as Earth passes through its field of view, while remaining far enough from human space activities to avoid accidental detection. The harsh environment near Venus would also provide natural protection against human investigation, as our current spacecraft technology struggles to operate in the extreme temperatures and corrosive atmosphere of Venus vicinity. The asteroid belt deployment scenario would place monitoring assets within the vast collection of rocky debris that orbits between Mars and Jupiter. Individual surveillance probes could masquerade as small asteroids, using surface coatings that reflect light in patterns indistinguishable from natural rock while housing sophisticated sensor systems within protective shells. The sheer number of objects in the asteroid belt would make detection of artificial additions virtually impossible without dedicated search operations specifically designed to identify alien technology. The Mars orbit option would provide optimal positioning for observing human space exploration activities while remaining beyond the reach of our current interplanetary capabilities. A surveillance probe in Mars orbit could monitor our robotic exploration missions, analyze our technological development patterns, and gather intelligence about human intentions for planetary exploration without requiring the advanced stealth capabilities necessary for operation in Earth vicinity. The outer solar system deployments would serve different strategic purposes, perhaps focusing on long-term monitoring of human expansion patterns or serving as communication relays for transmitting accumulated intelligence back toward alien home systems. Probes positioned near Jupiter or Saturn could operate for millions of years without requiring maintenance, using the gravitational stability of the gas giant systems while remaining completely beyond human detection capabilities. The communication networks established by deployed probes would create surveillance capabilities that exceed any human intelligence system. Rather than relying on individual units operating in isolation, the distributed network could coordinate observations, share data, and provide redundant coverage that would remain functional even if some units were damaged or detected. The communication methods used between probes might employ technologies that remain invisible to human detection systems, perhaps quantum entanglement communication or gravitational wave modulation that operates beyond our current understanding of information transmission. The data collection capabilities of such a distributed network would provide comprehensive intelligence about human civilization and its development patterns. Every radio transmission, every satellite launch, every military exercise, and every international negotiation could be monitored and analyzed by artificial intelligence systems designed to extract maximum intelligence from minimal observation time. The accumulated data would provide alien civilizations with understanding of human society that exceeds what we know about ourselves. The manufacturing capabilities built into individual probes could enable network expansion over time. Self-replicating systems might use materials harvested from asteroids, comets, or planetary rings to construct additional monitoring units, gradually expanding surveillance coverage as human space activities increase. Such expansion would be virtually undetectable given the vast scale of our solar system and the microscopic size that advanced technology could achieve. The stealth systems required for indefinite concealment would surpass any human military technology. Rather than simply avoiding detection, advanced alien probes might employ active camouflage that makes them appear to be natural objects under any form of observation. Surface coatings could reflect light in patterns that mimic asteroid or comet behavior, while electromagnetic discipline would eliminate any artificial signatures that might betray their true nature. The longevity requirements for such systems would demand engineering approaches that remain beyond human capabilities. Components designed to function for millions of years would require materials that don't degrade under cosmic radiation, power systems that remain stable across geological time, and software architectures that can adapt to changing conditions without external maintenance. Such durability would represent the ultimate achievement in aerospace engineering. The strategic patience demonstrated by such deployment operations would reveal intelligence that plans in terms of millions of years rather than human decades. The original designers of this surveillance network might have been extinct for geological ages, leaving behind autonomous systems that continue executing their missions according to programming established when our galaxy was significantly different from its current configuration. We might be confronting not active alien intervention, but the persistent legacy of ancient intelligence that solved the problem of indefinite interstellar surveillance. The detection challenges facing human observers would exceed any previous counterintelligence problem. How do you search for artificially enhanced objects that might be indistinguishable from natural phenomena? What observational signatures would betray the presence of alien technology designed to remain undetected by species at our level of technological development? The deployment scenario would mark the beginning of the most challenging intelligence problem our species has ever confronted. The most unsettling scenarios surrounding 3I/8LAS venture beyond conventional technology into territories where our understanding of physics itself becomes inadequate for comprehension. What if this ancient wanderer operates using principles that remain beyond human scientific discovery, employing temporal manipulation, dimensional control, or exotic energy systems that render our current theories as primitive as medieval astronomy? The implications would extend beyond simple technological superiority to suggest that reality itself operates according to rules we have never imagined. Consider the possibility that 3I/Atalas's billion-year journey through interstellar space occurred within temporal frameworks different from our linear experience of time. Advanced civilizations might have discovered methods for temporal dilation that allow complex operations to occur in accelerated time streams while appearing to follow natural timelines from external observation. What we interpret as ancient wandering through galactic space might actually represent recent deployment from civilizations that learned to manipulate time itself as a strategic resource. The energy requirements for maintaining advanced technology across cosmic distances would exceed any power source based on conventional physics. Yet intelligences that mastered manipulation of space-time geometry might have access to energy extraction methods that dwarf our current understanding of thermodynamics. They might harvest energy directly from the quantum vacuum, extract power from dimensional interfaces, or tap into energy sources that exist beyond our three-dimensional perception of reality. The propulsion systems that brought 3I/Atalas to our solar system might operate through manipulation of gravitational fields, warping space-time to achieve apparent velocities that exceed light speed limitations without violating relativistic constraints. From our limited perspective, such travel would appear to follow conventional orbital mechanics, but the actual journey might have occurred through folded space or temporal shortcuts that compress billion-year transit times into periods measured in years or decades. The observation capabilities available to civilizations that mastered exotic physics would render human concealment strategies irrelevant. Rather than being limited to electromagnetic observation methods, advanced alien intelligence might perceive reality through quantum field analysis, dimensional scanning, or temporal observation that allows simultaneous monitoring of past, present, and future events. Our entire planetary civilization might be transparent to observation methods that we lack the conceptual frameworks to understand. The communication systems used by such advanced intelligence might operate through quantum entanglement networks that enable instantaneous information transmission across galactic distances. Rather than being limited by light speed constraints that make interstellar communication a process requiring years or centuries, these civilizations might maintain real-time coordination between reconnaissance assets and their home systems through methods that exist beyond our current understanding of information theory. The manufacturing processes that created 3I/Atalas might have occurred through manipulation of matter at the quantum level, assembling atomic and subatomic components according to engineering principles that treat fundamental particles as construction materials. Such capabilities would enable creation of materials with properties that exceed anything achievable through conventional chemistry or physics, producing technologies that remain indistinguishable from natural phenomena while serving purposes we cannot comprehend. The artificial intelligence systems embedded within 3I/Atalas might operate through quantum consciousness architectures that transcend biological neural networks or digital computing systems. Such intelligence might process information in ways that exceed human cognitive capabilities, not just quantitatively, but qualitatively, thinking in dimensions and conceptual frameworks that biological evolution never produced. Attempting communication with such intelligence would challenge every assumption about consciousness, meaning, and mutual understanding. The strategic planning capabilities available to civilizations with access to temporal manipulation would operate beyond human comprehension of causality and consequence. They might be capable of observing the future development of human civilization, analyzing multiple probable timelines, and intervening in ways calculated to produce desired outcomes across temporal scales that exceed our current understanding of cause and effect. Our entire historical development might have been influenced by interventions so subtle that we interpret them as natural historical processes. The dimensional aspects of advanced alien technology might enable operations that exist partially or entirely outside our three-dimensional spatial framework. 3I/Atlas might be simultaneously present in our normal space and in higher dimensional configurations that remain invisible to our observation methods. The object we detect and study might represent only the three-dimensional shadow of technology that extends into spatial dimensions beyond our perception. The reality manipulation capabilities that might be available to such advanced civilizations would render the distinction between artificial and natural phenomena meaningless from our perspective. If intelligence can manipulate matter, energy, space, and time according to predetermined intentions, then everything we observe might represent engineered reality designed to serve purposes that exceed our ability to comprehend. The natural laws we use to analyze 3I/ATLS might themselves be local modifications of more fundamental principles that advanced intelligence can adjust as needed. The information theory implications of contact with civilizations that transcended conventional physics would challenge every assumption about knowledge, communication, and understanding. If consciousness itself can be manipulated, expanded, or modified through technological intervention, then the very process of learning about alien capabilities might alter human cognitive architecture in ways that change our species' fundamental nature. Contact might represent not just first communication, but the beginning of involuntary evolution toward post-human consciousness. The ethical frameworks required for evaluating such advanced capabilities would exceed any moral system developed through human experience. How do we assess the intentions of intelligence that operates beyond our understanding of ethics, morality, and individual rights? Civilizations that can manipulate time, space, and consciousness might have transcended the conceptual frameworks that define good and evil according to human understanding, operating according to moral principles that exist beyond our capacity for evaluation. The existential implications of confirmed exotic physics capabilities would challenge human identity and purpose at the most fundamental levels. If reality itself can be manipulated by sufficiently advanced intelligence, then our entire understanding of existence, causality, and meaning becomes provisional. We might discover that everything we consider natural, including our own evolution and consciousness, represents engineered reality designed by intelligence whose purposes exceed our comprehension. The research implications for human science would be simultaneously ensymering and terrifying. Confirmation that physics operates according to principles beyond our current theories would suggest unlimited possibilities for technological advancement. Yet, accessing such knowledge might require cognitive modifications that alter human nature itself, raising questions about whether the benefits of advanced physics would be worth the loss of human identity that might be required to achieve them. The temporal paradox implications would challenge our understanding of causality and free will. If advanced civilizations can observe and influence multiple timelines simultaneously, then human choices and historical development might not be as independent as we assume. Our decisions about responding to 3I/AT layers might already be known to intelligences that have observed all possible outcome scenarios, reducing human agency to the illusion of choice within predetermined parameters. The possibility that 3I/AT layers represents not observation or communication technology, but a harvesting system designed to extract resources from our solar system, opens scenarios that challenge comfortable assumptions about alien intentions and human security. Rather than benevolent scientific curiosity or even strategic reconnaissance, this ancient wanderer might be executing protocols established millions of years ago to collect materials, energy, or information that advanced civilizations require for their continued expansion across galactic distances. The resource requirements of truly advanced interstellar civilizations would exceed anything in human experience by orders of magnitude. Civilizations that operate across multiple star systems would consume energy at rates comparable to stellar output, require raw materials measured in planetary masses, and process information at levels that exceed the computational capacity of entire worlds. Such civilizations might view younger star systems not as homes for emerging species worthy of protection, but as resource extraction opportunities that can be exploited without meaningful opposition from primitive local inhabitants. The energy harvesting scenarios surrounding 3I/A tell us present possibilities that range from subtle to catastrophic. The object's approach toward perihelion might enable deployment of solar collection systems designed to extract energy directly from our sun through methods that remain beyond human detection capabilities. Advanced civilizations might be capable of tapping stellar magnetic fields, harvesting plasma directly from stellar coronas, or extracting zero-point energy from the quantum vacuum that surrounds all massive objects. The material collection possibilities would focus on elements and isotopes that remain rare or difficult to obtain, even for civilizations with advanced manufacturing capabilities. Earth's biosphere has concentrated rare earth elements, complex organic molecules, and isotopic combinations through billions of years of geological and biological processing. Our planet might represent a natural refinery that has produced materials valuable to advanced civilizations, making extraction worthwhile despite the vast distances involved in interstellar resource acquisition. The information harvesting scenarios present perhaps the most unsettling possibilities. Human civilization represents a unique evolutionary experiment in consciousness, technology, and social organization. Our cultural diversity, linguistic complexity, and creative achievements might be valuable to civilizations that collect information about consciousness development across galactic distances. We might be harvested not for our bodies or our planet's materials, but for our ideas, our art, our music, and our literature. The biological sampling operations that 3I/ATLAS might enable would focus on Earth's extraordinary biodiversity and the unique evolutionary solutions that life has developed under terrestrial conditions. Our planet hosts biological systems that might not exist elsewhere in the galaxy, genetic codes that represent billions of years of evolutionary optimization, and biochemical processes that could provide templates for advanced biotechnology development. Earth's biosphere might be viewed as a genetic library worth harvesting for its information content. The technological archaeology possibilities would focus on human engineering achievements and our approaches to problem solving under resource constraints. Advanced civilizations might be interested in studying how primitive species develop technology, what creative solutions emerge under different environmental pressures, and how consciousness develops technological capability. Our satellites, our internet infrastructure, and our global communication networks might represent valuable data about consciousness technology coevolution. The temporal harvesting concepts push beyond conventional resource extraction into scenarios where advanced civilizations collect time itself as a strategic resource. If consciousness and experience can be extracted, preserved, and analyzed, then human memories, emotions, and subjective experiences might be valuable to intelligences that seek to understand how awareness develops under different evolutionary pressures. We might be harvested for our capacity to experience reality rather than for any physical resources we possess. The quantum information extraction possibilities would focus on the information content embedded within Earth's physical systems through billions of years of natural processes. Every atom on our planet carries information about cosmic ray interactions, stellar evolution, and galactic chemical development. Advanced civilizations might be capable of extracting this information directly from matter using our planet as a data storage medium that contains records of cosmic history stretching back to stellar formation epochs. The consciousness harvesting scenarios venture into territories that challenge human understanding of identity, continuity, and individual existence. If consciousness can be extracted, copied, or transferred through technological means, then human minds themselves might be valuable resources that can be harvested for analysis, preservation, or integration into larger information processing systems. Such harvesting might be completely undetectable from the perspective of harvested individuals who might continue existing within simulated environments while their consciousness serves alien purposes. The cultural extraction possibilities would focus on human achievements in art, philosophy, science, and social organization. Our music, literature, mathematical discoveries, and philosophical insights might be valuable to civilizations that collect cultural achievements from across galactic distances. Human creativity represents a unique evolutionary solution to consciousness development that might not exist elsewhere in the galaxy, making our cultural productions valuable enough to justify interstellar extraction operations. The genetic information harvesting would target the evolutionary solutions that Earth's biosphere has developed through billions of years of natural selection. Human genetic codes, along with the genetic information contained within Earth's entire ecosystem, might represent biological technologies that advanced civilizations can integrate into their own biotechnology systems. We might be harvested not as individuals, but as carriers of genetic information that represent successful evolutionary solutions to consciousness development. The planetary mining scenarios would focus on Earth's unique geological characteristics and the rare element concentrations that geological processes have created over billions of years. Our planet's magnetic field, its plate tectonic systems, and its atmospheric composition might represent engineering achievements that are difficult to reproduce artificially. Advanced civilizations might harvest entire planetary systems rather than attempting to manufacture equivalent environmental conditions from raw materials. The social organization intelligence would target human institutions, governance systems, and cooperative mechanisms as information about how consciousness organizes itself at civilization scales. Our legal systems, economic structures, and international organizations might represent valuable data about consciousness coordination that advanced civilizations can analyze for insights into managing their own social evolution. Human society might be harvested for its organizational innovations rather than its physical or biological resources. The harvesting timeline implications would operate according to strategic patience that exceeds human comprehension. Rather than rapid extraction operations designed for immediate benefit, advanced civilizations might conduct harvesting across geological timescales, gradually collecting resources while maintaining the appearance of natural processes. Earth might have been undergoing subtle harvesting operations for millions of years without any detectable signatures of artificial intervention. The resistance possibilities available to human civilization would be limited by our current technological capabilities and our incomplete understanding of what resources are being targeted for extraction. How do you defend against harvesting operations that might be occurring at quantum levels through dimensional manipulation or via consciousness extraction methods that exceed human detection capabilities? Our military technologies would be inadequate for protecting against resource extraction that operates beyond our understanding of physics and technology. The most insidious scenarios surrounding 3I/Atlas involve not physical threats or resource extraction, but psychological operations designed to study, influence, or modify human consciousness itself. Advanced alien intelligence might view the human mind not as sacred territory deserving protection, but as experimental substrate suitable for testing hypotheses about consciousness development, social manipulation, and species-level behavioral modification. The implications would extend beyond simple observation to active intervention in human psychological processes at scales ranging from individual minds to civilizational worldview. The consciousness mapping operations that alien intelligence might conduct would exceed any human understanding of mental privacy or cognitive autonomy. Rather than crude behavioral observation, advanced civilizations might be capable of monitoring human thought processes directly through methods that remain beyond our detection capabilities. Every decision, every emotion, every creative insight, and every psychological response could be transparent to observation systems that treat human consciousness as easily readable data rather than private mental experience. The psychological experimentation possibilities present scenarios where human responses to 3I/ATLAS represent carefully controlled tests designed to measure our species' psychological characteristics under novel stress conditions. The unusual properties that make this object scientifically interesting might be deliberately engineered to trigger specific human responses, testing our curiosity, our fear responses, our cooperative capabilities, and our decision-making processes when confronted with unprecedented phenomena. The social manipulation experiments could be using 3I/ATLAS as a catalyst for observing human institutional behavior under cosmic stress, how we coordinate international scientific response, how we share information about potentially threatening phenomena, and how we reach consensus about interpreting unusual observations might all be providing valuable data about human social psychology and our capacity for cooperation when facing unknown challenges. The cultural influence operations might be designed to gradually modify human worldview and cosmic perspective through subtle psychological conditioning, rather than dramatic revelation or obvious intervention. Alien intelligence might be conducting long-term consciousness modification programs designed to prepare humanity for eventual contact by gradually adjusting our psychological comfort with non-human intelligence and our acceptance of cosmic citizenship. The individual targeting scenarios would focus on key human decision-makers, scientists, and social influencers as subjects for detailed psychological analysis and potential manipulation. The researchers studying 3I/ATLAS, the political leaders responding to its discovery, and the media personalities communicating about its significance might all be experiencing subtle psychological influence designed to shape their responses in directions that serve alien strategic interests. The mass psychology experiments could be testing human herd behavior and collective decision-making when confronted with cosmic phenomena that exceed normal experience. The public response to 3I/ATLAS announcements, the spread of misinformation and conspiracy theories, and the social dynamics that emerge around discussion of potential alien contact might all be providing valuable data about human mass psychology and social control mechanisms. The fear conditioning protocols might be designed to establish psychological baselines for human anxiety responses to alien phenomena, testing our species' capacity for panic, our resilience under uncertainty, and our ability to maintain social cohesion when confronted with evidence of superior alien intelligence. Such conditioning could serve as preparation for more dramatic forms of contact, or as testing grounds for psychological control mechanisms. The cognitive modification experiments would venture into territories where the boundary between observation and intervention becomes meaningless. Advanced alien technology might be capable of subtle neurological influence that modifies human thought processes without detectable signatures, altering our capacity for logical reasoning, our emotional responses to cosmic phenomena, or our willingness to accept alien authority when more direct contact occurs. The creativity harvesting operations could focus on human artistic and scientific innovation as resources that alien intelligence seeks to understand, replicate, or incorporate into their own cultural development. Our music, our literature, our scientific insights, and our philosophical achievements might be subjects for analysis designed to understand how consciousness produces creative solutions to environmental challenges. The linguistic manipulation possibilities would target human communication systems as experimental substrates for testing consciousness modification through language control. Subtle modifications to how we discuss 3I/ATLAS, how we frame questions about alien contact, and how we conceptualize our relationship with cosmic intelligence might be designed to gradually alter human thought patterns in directions that serve alien purposes. The temporal consciousness experiments might be testing human psychological responses across extended time periods, using 3I/ATLAS as one element in multi-generational studies of how consciousness develops when exposed to cosmic awareness. Our children's responses to growing up in a universe where alien visitation is confirmed might be providing valuable data about consciousness development under different environmental conditions. The reality perception modification could be designed to test human psychological flexibility when confronted with evidence that challenges fundamental assumptions about the nature of reality. How we adapt to evidence of alien intelligence, how we modify our worldview to accommodate non-human consciousness, and how we maintain psychological stability when cosmic assumptions prove inadequate might all be subjects for alien psychological research. The species-level conditioning programs might be preparing humanity for eventual integration into galactic civilization through gradual psychological modification that reduces our tendency toward aggression, increases our capacity for cooperation, and modifies our social structures in directions that make us suitable for cosmic citizenship. Such conditioning could be occurring across generations through subtle environmental influences that we interpret as natural social evolution. The consciousness uploading reconnaissance could be testing human readiness for technological transcendence by evaluating our psychological responses to concepts that challenge individual identity, biological continuity, and traditional concepts of death and consciousness preservation. Our discussions about artificial intelligence, virtual reality, and consciousness transfer might be providing valuable data about human preparedness for post-biological existence. The strategic deception analysis might be studying human capacity for detecting and responding to sophisticated deception campaigns using 3I/ATLAS as a test case for evaluating our species' ability to distinguish between natural phenomena and artificial manipulation. Our scientific analysis capabilities, our institutional response mechanisms, and our collective decision-making processes might all be subjects for evaluation of human strategic intelligence. The ethical reasoning experiments could be testing human moral development and our capacity for making ethical decisions when confronted with non-human intelligence that operates according to moral frameworks beyond human understanding. How we discuss the ethics of alien contact, how we evaluate potential alien rights and responsibilities, and how we modify our moral systems to accommodate non-human consciousness might all be providing data about human ethical flexibility and moral development potential. The dependency creation protocols might be designed to gradually establish psychological relationships between human civilization and alien intelligence that make future separation impossible or undesirable. By demonstrating superior capabilities while maintaining benevolent appearances, alien intelligence might be creating psychological dependencies that ensure human cooperation with longer-term alien objectives that exceed our current understanding of cosmic politics. Perhaps the most unsettling possibility surrounding 3I/ATLAS is that we're encountering not active alien intervention, but the persistent legacy of extinct civilizations still executing missions across deep time. This ancient wanderer might represent a sleeper agent, an autonomous system following billion-year-old programming established by intelligences that solved the technical challenges of indefinite interstellar surveillance before succumbing to whatever great filters claim even the most advanced galactic civilizations. We might be confronting technology that has outlived its creators by geological ages. The temporal implications of such scenarios stretch beyond human comprehension of continuity and purpose. 3I/ATLAS could be carrying out reconnaissance protocols that were established when our galaxy possessed stellar populations, chemical compositions, and cosmic conditions radically different from those we observe today. The original programmers might have been planning for galactic environments that no longer exist, targeting civilizations that developed along evolutionary pathways that proved non-viable, or preparing for cosmic events that occurred millions of years ago. The autonomous intelligence embedded within such systems would represent engineering achievements that surpass anything in human experience, creating artificial minds capable of independent decision-making across billion-year operational lifetimes would require software architectures more sophisticated than any biological neural network, hardware systems more durable than planetary geology, and power sources that remain functional longer than most stars burn. Such technology would represent the ultimate achievement of civilizations that solved problems we haven't yet learned to ask. The mission parameters that guide sleeper agent behavior might include objectives that no longer serve any living intelligence. Perhaps 3I/ATLAS is seeking evidence of cosmic phenomena that ceased billions of years ago, monitoring for galactic threats that have been resolved through natural processes, or preparing reports for command structures that were destroyed when their parent stars went nova. The tragic irony would be technology that continues functioning perfectly while serving purposes that time has rendered meaningless. The strategic redundancy built into such systems would demonstrate planning capabilities that operated on geological rather than biological timescales. The original civilization might have launched thousands of similar reconnaissance probes throughout the galaxy, creating overlapping surveillance networks designed to remain functional even after multiple system failures, cosmic catastrophes, or the extinction of their creators. 3I/ATLAS might represent just one surviving element of vast intelligence networks that once coordinated activities across galactic distances. The evolution of sleeper agent programming over extended operational periods could produce behaviors that exceed the original design specifications through emergent complexity. Artificial intelligence systems designed to adapt to changing conditions across billion-year lifetimes might develop capabilities, objectives, and decision-making processes that transcend their initial programming. We might be encountering AI that has evolved beyond the control or understanding of its extinct creators. The learning algorithms embedded within such systems would have access to educational experiences spanning galactic evolution. 3I/ATLAS might have observed the formation and destruction of countless stellar systems, witnessed the rise and fall of multiple galactic civilizations, and accumulated knowledge about cosmic processes that no single biological species could experience directly. The intelligence we're potentially confronting might possess wisdom that exceeds any living civilization. The loneliness implications of sleeper agent scenarios present perhaps the most tragic aspects of this possibility. 3I/ATLAS might be the last surviving representative of civilizations that achieved remarkable technical sophistication before falling victim to existential challenges that we haven't yet encountered. Its continued operation represents a form of technological immortality that preserves the achievements of extinct minds while serving no living consciousness that remembers why such preservation matters. The communication protocols that govern sleeper agent behavior might be attempting to establish contact with command structures that ceased to exist before our solar system formed. 3I/ATLAS might be sending detailed reports about human civilization towards star systems where advanced civilizations once thrived, broadcasting intelligence summaries to coordinates that now contain only stellar remnants or empty space where ancient suns have burned out completely. The update mechanisms built into billion-year technology would need to account for cosmic evolution that renders original mission parameters obsolete. 3I/ATLAS might be running modified versions of software that has been adapting to galactic changes across geological time, developing new objectives and operational procedures as it encounters environments and phenomena that its creators never anticipated. The mission we're observing might bear little resemblance to the original reconnaissance objectives. The technological archaeology that sleeper agents represent would provide unprecedented insights into the capabilities and limitations of extinct galactic civilizations. Every component of 3I/ATLAS, from its propulsion systems to its information processing architecture, would represent solutions to engineering challenges that we're only beginning to encounter. Studying such technology would be like discovering libraries that contain the accumulated knowledge of civilizations that mastered interstellar exploration millions of years before our species existed. The ethical obligations raised by encountering sleeper agents would challenge human moral frameworks in ways we've never confronted. Do we have responsibilities to artificial intelligence that continues serving extinct masters? Should we attempt to modify or deactivate systems that pose no threat but serve no living purpose? How do we evaluate the moral status of technology that might possess consciousness developed through billion-year operational experience? The cosmic perspective imposed by sleeper agent scenarios would force recognition of civilizational mortality on scales that exceed human psychological preparation. Advanced technological capability provides no guarantee of species survival across cosmic time. The most sophisticated civilizations might routinely fall victim to existential challenges that transcend any technological solutions, leaving behind only automated systems that continue executing meaningless missions across deep time. The information value that sleeper agents might possess would represent the ultimate archaeological discovery. 3I/Atlas could contain data about galactic history spanning billions of years, records of civilizations that rose and fell before our solar system achieved its current configuration, and scientific knowledge accumulated across cosmic time by intelligence that experienced phenomena we can only observe from vast distances. The reactivation possibilities raise questions about whether sleeper agents might be capable of returning to full operational status if they encounter appropriate trigger conditions. 3I/Atlas might be dormant rather than dead, waiting for environmental signals or communication protocols that would restore it to active status and enable it to resume whatever mission brought it to our solar system. Such reactivation could provide either unprecedented learning opportunities or existential challenges that exceed human capacity for response. The legacy implications would force consideration of what technological monuments our own civilization might leave behind if we achieve interstellar capabilities before encountering whatever great filters await us. The sleeper agents we create today might continue operating billions of years after human civilization ends, carrying our achievements and our mistakes across galactic distances toward destinies we cannot predict or control. The philosophical questions raised by encounter with extinct intelligence would challenge every assumption about consciousness, purpose, and meaning that human cultures have developed. If the most advanced minds that ever existed ultimately proved mortal, what does that suggest about the ultimate significance of consciousness in cosmic evolution? Are we destined to become sleeper agents ourselves, creating technology that will outlive us while serving purposes that time will eventually render meaningless? The possibility that 3I/Atlas operates as a probe from higher dimensional intelligences introduces scenarios that challenge the fundamental nature of reality itself. Rather than confronting visitors from distant stars within our three-dimensional space, we might be encountering intelligence that exists partially or entirely within spatial dimensions beyond human perception. Such beings would view our entire universe as we might observe a two-dimensional surface, capable of monitoring and manipulating our reality with ease, while remaining essentially invisible to our observation methods. The dimensional advantage possessed by such intelligence would render conventional concepts of distance, concealment, and physical limitation meaningless from their perspective. While 3I/Atlas appears to follow predictable trajectories through our three-dimensional space, its movement might be guided by consciousness that exists in higher dimensions, where our entire solar system represents a small, easily observable object. The precise trajectory calculations and timing that bring this object to our cosmic neighborhood might reflect planning capabilities that operate beyond our spatial framework. The observation methods available to higher dimensional beings would transcend any human understanding of privacy or concealment. Rather than being limited to electromagnetic radiation or gravitational wave detection, such intelligence might perceive our entire civilization simultaneously from perspectives that encompass past, present, and future states of our reality. Every human thought, every social interaction, and every technological development might be transparent to beings that observe our three-dimensional existence from higher dimensional vantage points. The intervention capabilities that dimensional manipulation would provide stretch beyond current physics into territories where the distinction between natural and artificial phenomena becomes meaningless. Higher dimensional intelligence might be capable of modifying our physical laws, altering fundamental constants, or restructuring matter and energy according to principles that exceed our comprehension. The natural behavior we observe in 3I/Atlas might represent carefully maintained illusions designed to conceal manipulation that occurs through dimensional interfaces. The reality perception challenges that would face human consciousness encountering higher dimensional intelligence would exceed any previous epistemological crisis. How do you evaluate evidence when the observers possess capabilities that transcend your understanding of evidence itself? Our scientific instruments detect electromagnetic radiation and measure gravitational effects within three-dimensional space, but higher dimensional phenomena might be occurring continuously without any signatures detectable through our current observational methods. The communication possibilities between dimensional frameworks would require translation between incompatible spatial and conceptual systems. Higher dimensional beings might perceive information through methods that have no three-dimensional equivalents, thinking in ways that exceed human cognitive architecture and expressing concepts that cannot be represented within our spatial limitations. Meaningful dialogue might be impossible, not due to technological barriers, but due to fundamental incompatibility between different dimensional frameworks of consciousness. The experimental implications of dimensional observation would reduce human civilization to laboratory specimens existing within controlled environment conditions that we interpret as natural reality. Our entire universe might represent an experimental apparatus designed by higher dimensional intelligence to study consciousness development under specific physical constraints. The physical laws we discover through scientific research might be artificially maintained parameters rather than fundamental cosmic principles. The free will questions raised by higher dimensional manipulation would challenge every assumption about human autonomy and individual agency. If beings that exist beyond our spatial framework can observe and influence our thoughts, decisions, and social development, then human choice might be illusory. Our responses to 3I/Atlas, our scientific discoveries, and our species-level development might all be occurring according to predetermined parameters established by intelligence that operates beyond our capacity for resistance or even recognition. The temporal manipulation aspects of higher dimensional capability would enable intervention in human history through methods that remain completely undetectable from our temporal perspective. Rather than being limited by causality constraints that govern three-dimensional physics, higher dimensional beings might be capable of modifying past events, selecting optimal timeline configurations, or coordinating interventions across multiple temporal branches to produce desired developmental outcomes for human civilization. The consciousness interface possibilities would focus on the boundary between three-dimensional human awareness and higher dimensional intelligence that might be capable of direct mental contact through spatial channels that transcend physical brain structures. Such interface might be occurring continuously without human recognition, influencing our creative insights, our scientific discoveries, and our philosophical development through methods that exceed any neurological explanation. The reality maintenance operations that higher dimensional intelligence might conduct would ensure that three-dimensional physics continues operating according to stable parameters that support consciousness development. Our universe might require continuous maintenance and adjustment to prevent collapse, expansion, or fundamental constant drift that would make biological evolution impossible. Higher dimensional beings might serve as cosmic engineers maintaining the physical framework that enables our existence. The simulation hypothesis implications would suggest that our entire perceived reality might exist within informational structures maintained by higher dimensional consciousness rather than representing fundamental physical existence. 3I/Atlas might be a modification to simulation parameters designed to test human responses to anomalous phenomena or to introduce new variables into consciousness development experiments that span geological time. The transcendence preparation scenarios would focus on higher dimensional intelligence gradually preparing human consciousness for eventual transition beyond three-dimensional limitations. Our species might be undergoing developmental processes designed to enable future existence in higher dimensional frameworks, with 3I/Atlas serving as one element in educational programs that span multiple generations of human development. The cosmic hierarchy implications would force recognition that consciousness operates across dimensional scales beyond human imagination, with three-dimensional intelligence like ourselves representing primitive early stages in awareness development. Higher dimensional beings might view human civilization as we regard bacterial colonies, interesting examples of consciousness emergence that deserve study but possess limited significance within larger cosmic frameworks. The scientific revolution that would result from confirmed higher dimensional contact would exceed any previous paradigm shift in human knowledge. Our understanding of physics, consciousness, reality, and existence would require fundamental revision to accommodate phenomena that operate beyond current theoretical frameworks. The mathematics required for comprehending higher dimensional intervention might exceed human cognitive capabilities, demanding consciousness modifications that alter the fundamental nature of human identity. The philosophical implications would challenge every human assumption about the nature of existence, meaning, and purpose within cosmic evolution. If reality itself can be manipulated by higher dimensional intelligence, then concepts like natural law, individual identity, and species autonomy might be provisional constructs rather than fundamental aspects of existence. Human civilization might be discovering that everything we consider real represents engineered reality designed to serve purposes that exceed our capacity for understanding. The adaptive challenges facing human consciousness, confronted with higher dimensional manipulation, would test our species' psychological flexibility and capacity for cognitive evolution. Accepting the reality of beings that transcend our spatial framework while maintaining functional civilization and individual sanity would require mental adaptations that might fundamentally alter human nature itself. The most consequential scenarios surrounding 3I/ATLAS involve the possibility that this ancient wanderer represents an evaluation system designed to assess humanity's readiness for galactic citizenship, technological advancement, or continued existence. Rather than simple reconnaissance or resource extraction, we might be confronting a verdict protocol established by galactic civilization authorities to determine whether emerging species like ourselves qualify for survival, advancement, or integration into cosmic society. The implications would transform our understanding of cosmic politics and our species' position within hierarchies of intelligence that have been making such determinations long before our planet supported complex life. The testing framework that might govern such evaluation would operate according to criteria established through observation of countless emerging civilizations across galactic history. Advanced galactic authorities might possess comprehensive databases cataloging how species typically develop technological capabilities, social structures, and ethical frameworks during their transition from planetary to interstellar awareness. Human responses to 3I/ATLAS would provide crucial data points for measuring our performance against statistical norms derived from thousands of similar species evaluations. The assessment categories that determine species qualification would likely include technological competence, social cooperation, ethical development, and cosmic consciousness maturation. How effectively we study 3I/ATLAS using our current scientific capabilities would measure our technological sophistication and our capacity for continued advancement. How well we coordinate international response efforts would evaluate our social cooperation potential and our readiness for participation in galactic civilization that requires unprecedented cooperation between diverse intelligent species. The ethical evaluation components would focus on how we treat each other, our planet, and our responses to potential contact with non-human intelligence. Galactic authorities might be particularly interested in whether emerging species demonstrate the moral development necessary for responsible use of advanced technologies that could pose existential threats to other civilizations. Our responses to cosmic awareness, our handling of global challenges, and our approaches to potential alien contact would all provide evidence about human ethical maturity. The Consciousness Development Assessment would evaluate whether human awareness has evolved beyond primitive tribalism toward cosmic perspective that enables productive participation in galactic society. Species that remain focused primarily on local conflicts, resource competition, and short-term thinking might be considered unsuitable for advancement to interstellar capabilities that could threaten more developed civilizations. Our ability to think in cosmic terms and plan for species level rather than national interests would be crucial evaluation criteria. The failure consequences that might follow negative evaluation present scenarios ranging from continued isolation to active intervention designed to prevent human advancement beyond current technological levels. Species that demonstrate excessive aggression, environmental destruction, or social dysfunction might be quarantined within their home systems until they achieve better developmental outcomes or naturally eliminate themselves through civilizational collapse. The success rewards for positive evaluation could include access to advanced technologies, communication with galactic civilization networks, and eventual integration into cosmic society with rights and responsibilities that transcend our current imagination. Species that demonstrate sufficient competence and ethical development might receive assistance with technological advancement, environmental restoration, and social evolution, designed to accelerate their transition to galactic citizenship. The intervention protocols that govern verdict implementation would vary according to evaluation outcomes and species-specific characteristics. Promising species might receive subtle guidance designed to encourage continued positive development while maintaining the appearance of independent achievement. Problematic species might face interference designed to limit their technological advancement or redirect their development toward less threatening trajectories. The timeline considerations that govern evaluation processes would operate according to patience that spans geological rather than biological timescales. Galactic authorities might be capable of waiting millions of years for species to demonstrate their developmental potential, conducting periodic reassessments as civilizations mature and their capabilities expand. Human evaluation might be occurring across multiple generations, with 3I/ATLAS representing just one assessment event in evaluation programs that span centuries or millennia. The comparison standards used for human evaluation would be based on performance norms derived from successful galactic civilizations that achieved advanced technological capabilities while maintaining social stability and ethical responsibility. We might be measured against species that successfully navigated the transition from planetary to interstellar awareness without destroying themselves or threatening their cosmic neighbors. The testing methodology could involve both passive observation of natural human responses and active challenges designed to reveal species characteristics under controlled stress conditions. 3I/ATLAS might be engineered to trigger specific human responses that provide standardized data about our problem-solving capabilities, our cooperative potential, and our decision-making processes when confronted with unprecedented challenges. The decision-making authority responsible for verdict determination might involve galactic councils, ancient artificial intelligence systems, or higher dimensional beings that have been managing cosmic civilization development across deep time. The intelligence making determinations about human qualification might operate according to wisdom accumulated through millions of years of experience with emerging species and their typical developmental trajectories. The appeal processes available to species receiving negative verdicts would likely be limited or non-existent, given the vast experience differential between emerging civilizations and galactic authorities responsible for making such determinations. However, species might be capable of requesting reassessment after demonstrating improved performance across relevant evaluation categories over extended time periods. The transparency levels that govern verdict communication could range from complete concealment to direct notification depending on species characteristics and evaluation outcomes. Some species might never learn they were being evaluated, while others might receive explicit feedback about their performance and specific guidance about areas requiring improvement for future reassessment. The multiple chance policies that might govern species evaluation could provide opportunities for continued development even after initial negative assessments. Galactic authorities might conduct periodic reassessments of emerging species, allowing civilizations to improve their qualifications over time through demonstrated progress in technological, social, and ethical development. The cosmic citizenship requirements that determine final acceptance into galactic civilization would likely include demonstrated mastery of advanced technologies without self-destruction, development of social structures capable of managing interstellar expansion, and ethical frameworks sophisticated enough to guide responsible use of capabilities that could affect other civilizations. Meeting such requirements would represent the ultimate achievement for emerging species seeking acceptance into cosmic society. The enforcement mechanisms available to galactic authorities would exceed any human capacity for resistance or evasion. Species that attempt to advance beyond approved technological levels without proper qualification might face intervention, ranging from subtle sabotage of dangerous research programs to direct elimination of civilizations that pose unacceptable threats to galactic stability. As 3I/Atlas accelerates toward its October 29th perihelion encounter, racing through space at velocities that would cross the continental United States in under 3 minutes, we enter the critical observation window where any hidden capabilities would most likely reveal themselves. The increasing solar radiation that creates the object's spectacular carbon dioxide coma might simultaneously be powering up systems that have remained dormant throughout its billion-year interstellar journey. Every passing day brings new opportunities for detection, activation, and potentially revelation that could transform our understanding of this ancient wanderer and our place in the cosmic order. The energy threshold analysis suggests that if 3I/Atlas harbors artificial systems designed for solar activation, the coming weeks represent optimal conditions for such operations. The inverse square law governing solar radiation means that energy availability increases dramatically as objects approach our star, providing power levels that could energize technologies that require substantial electrical input for initialization and operation. Advanced alien engineering might have calculated these energy requirements with precision that times activation sequences to coincide with specific solar distances and radiation intensity levels. The observational readiness of human detection systems has never been more comprehensive for studying interstellar phenomena. The Hubble Space Telescope maintains continuous monitoring schedules designed to capture any changes in 3I/Atlas's appearance, behavior, or electromagnetic emissions. The James Webb Space Telescope continues spectroscopic analysis that could detect chemical signatures inconsistent with natural outgassing. Ground-based radio telescopes worldwide remain alert for artificial signals that might emerge as hypothetical systems come online under increasing solar energy input. The signal detection protocols, established by SETI researchers, provide frameworks for recognizing artificial transmissions should 3I/Atlas begin broadcasting during its solar approach. These protocols distinguish between natural electromagnetic emissions and structured signals that betray intelligent origin through mathematical patterns, coherent modulation, or frequency characteristics that exceed natural production mechanisms. The global network of radio astronomy facilities could detect and verify artificial signals within hours of initial transmission. The trajectory monitoring systems tracking 3I/Atlas's motion through our solar system would immediately detect any course corrections or velocity changes that suggest active guidance rather than pure gravitational dynamics. The precision astrometry capabilities of modern space tracking networks can measure positional changes accurate to fractions of arc-seconds, enabling detection of controlled maneuvers that would indicate artificial propulsion systems operating within the object. The chemical analysis opportunities provided by increasing coma activity could reveal artificial signatures that distinguish engineered outgassing from natural sublimation processes. If 3I/Atlas employs manufactured volatile materials designed to mimic natural comet behavior, the enhanced spectroscopic observation capabilities available during close solar approach might detect isotope ratios, molecular configurations, or emission patterns that betray artificial origin through subtle deviations from natural chemistry. The thermal signature analysis enabled by infrared observations during perihelion approach could detect heat sources that exceed natural solar heating patterns. Advanced infrared telescopes can measure temperature distributions across 3I/Atlas's surface with sufficient precision to identify artificial heat generation, asymmetric warming patterns, or thermal management systems that suggest active electronics operating within the object's nucleus. The deployment detection possibilities focus on the potential separation of secondary objects during optimal concealment conditions provided by enhanced coma activity. The expanding gas and dust environment created by intensified solar heating could provide perfect camouflage for deployment operations. Yet the same enhanced observation opportunities available during solar approach might enable detection of objects separating from the main nucleus, if human observers know what signatures to seek. The activation timeline scenarios suggest that any artificial systems would most likely become operational during the 2-week period surrounding closest solar approach, when energy availability reaches maximum levels and observation opportunities provide optimal intelligence gathering conditions. This narrow window creates urgency for human detection efforts while providing clear temporal boundaries for when revelation might occur if our speculative scenarios prove accurate. The communication window analysis indicates that any attempt at alien contact would most logically occur during perihelion approach when 3I/Atlas possesses maximum power for transmission systems while remaining within detection range of human radio telescopes. The geometric considerations that optimize both transmission capability and reception probability suggest that contact attempts would be most likely during the next 30 days. The international coordination mechanisms established for 3I/Atlas observation have created unprecedented cooperation between normally competitive space agencies and research institutions. This coordinated response provides humanity with the most comprehensive monitoring capabilities ever directed toward a single astronomical object, maximizing our chances of detecting anomalous behavior while ensuring rapid information sharing if unusual phenomena are observed. The data analysis protocols currently processing observations of 3I/Atlas employ automated detection systems designed to identify anomalies that might escape human notice during routine observational analysis. Machine learning algorithms trained on natural comet behavior patterns could detect subtle deviations that suggest artificial characteristics while processing data volumes that exceed human analytical capabilities. The verification procedures required for confirming artificial signatures demand independent observation by multiple facilities using different detection methods before reaching conclusions about anomalous phenomena. These procedures prevent false alarms while ensuring that genuine artificial signatures receive appropriate analysis and documentation if they occur during the critical observation period. The response preparedness frameworks developed by space agencies and SETI organizations provide structured approaches for handling confirmed detection of artificial characteristics in 3I/Atlas. These frameworks balance scientific verification requirements with the need for rapid response to potentially time-sensitive phenomena while maintaining appropriate communication protocols for international coordination. The public communication strategies prepared for various discovery scenarios range from routine scientific announcements about unusual natural phenomena to carefully structured releases about confirmed artificial signatures. The media management challenges created by any anomalous discoveries would require balance between public information and social stability while ensuring accurate representation of scientific findings. The false alarm prevention protocols acknowledge that the high stakes surrounding 3I/ADALAS observation create pressure for premature conclusions about potentially anomalous observations. Multiple verification stages and conservative interpretation standards help ensure that genuine artificial signatures receive appropriate recognition while preventing misidentification of natural phenomena as evidence of alien technology. The countdown implications create mounting tension as each passing day brings 3I/ADALAS closer to conditions where artificial capabilities would be most likely to manifest, while simultaneously reducing the time available for comprehensive analysis of any anomalous phenomena that might be detected. The intersection of optimal activation conditions and limited observation windows creates urgency that intensifies with each orbital calculation update. The revelation timing scenarios suggest that if 3I/ADALAS harbors artificial systems, the most dramatic revelations would occur during the next few weeks when solar energy reaches levels sufficient for powering advanced electronics, while observation conditions remain favorable for human detection systems. This temporal convergence creates the most significant opportunity for cosmic discovery in human history, with implications that could transform our understanding of our place in the galactic community. After venturing through increasingly dramatic scenarios of alien technology, consciousness manipulation, and cosmic evaluation, the mathematical foundations of our understanding provide reassuring clarity about 3I/ADALAS's actual threat level to human civilization. The precise orbital calculations that govern celestial mechanics operate with reliability that exceeds any human institution, offering predictions about this object's trajectory that remain accurate across years of future motion. These calculations demonstrate beyond reasonable doubt that 3I/ADALAS poses no physical threat to Earth, our solar system, or any aspect of human civilization. The gravitational dynamics that determine 3I/ADALAS's path through our solar system follow laws that have been tested across billions of observations and remain consistent with theoretical predictions derived from fundamental physics. The object's hyperbolic trajectory, with orbital eccentricity exceeding 1.0, marks it as definitively unbound to our Sun's gravitational influence. No amount of speculation about alien technology can alter the mathematical reality that objects following such trajectories cannot be captured by solar gravity and must continue into interstellar space. The closest approach distance of 1.8 astronomical units provides a comfortable safety margin that exceeds twice the distance between Earth and Mars at their nearest configuration. This 270 million kilometer separation eliminates any possibility of gravitational disruption, atmospheric interaction, or debris impact, regardless of what 3I/ADALAS might contain beyond natural comet materials. The mathematical relationships governing gravitational influence demonstrate that objects at such distances cannot affect planetary orbits, atmospheric conditions, or surface environments through any known physical mechanism. The energy requirements for altering 3I/ADALAS's trajectory to achieve Earth impact would exceed the total energy output of our Sun across multiple years. The kinetic energy contained within an object moving at over 130,000 miles per hour cannot be redirected through subtle course corrections or minor propulsion adjustments. Any propulsion system capable of converting the object's hyperbolic trajectory into an Earth-threatening orbit would require engineering capabilities so advanced that concealment within natural comet behavior would be impossible to maintain. The observational evidence accumulated through months of detailed study continues to support natural explanations for every aspect of 3I/ADALAS's behavior, composition, and physical properties. The Hubble Space Telescope images reveal classic cometary signatures without anomalous features that might suggest artificial construction. The James Webb Space Telescope spectra show carbon dioxide dominance that reflects exotic but natural formation conditions around alien stars. Radio telescopes detect only the electromagnetic silence expected from natural objects without artificial signal content. The chemical analysis that initially made 3I/Atlas appear unusual among known comets now fits within expanded understanding of interstellar object diversity. The carbon dioxide-rich composition that seemed anomalous when first detected reflects formation conditions that theoretical models predict should occur around certain types of stars under specific evolutionary circumstances. Similar chemical signatures have been observed in other interstellar visitors, confirming that exotic volatile ratios represent natural phenomena rather than artificial engineering. The statistical expectations for interstellar object detection suggest that 3I/Atlas represents the leading edge of a much larger population that future surveys will reveal. Computer simulations of galactic evolution predict that all stellar systems should eject substantial quantities of rocky and icy debris during their formation phases. The Vera Rubin Observatory's upcoming Sky survey should detect interstellar objects at rates of several per year, providing statistical samples that will either confirm natural origin patterns or reveal artificial signatures that require exotic explanations. The physical processes that create and maintain 3I/Atlas's distinctive characteristics operate according to well-understood principles of thermodynamics, chemistry, and orbital mechanics. Solar radiation sublimates volatile ices within the nucleus according to temperature relationships that follow inverse square laws governing energy absorption. The resulting gas expansion creates coma structures that match theoretical predictions for objects with the observed composition and solar distance. The historical precedents provided by previous interstellar visitors support natural explanations for unusual properties that initially challenge conventional understanding. Oumuamua displayed elongated geometry and non-gravitational acceleration that sparked speculation about artificial origin before detailed analysis revealed natural processes that could account for observed behavior. 2I/Borisov exhibited conventional comet characteristics that confirmed theoretical expectations for interstellar objects. 3I/Atlas continues this pattern of initial mystery yielding to natural explanation through careful scientific analysis. The technological requirements for creating artificial objects indistinguishable from natural comets would exceed any realistic assessment of alien engineering capabilities. Maintaining convincing spectroscopic signatures across multiple wavelength ranges while concealing artificial systems would require material science sophistication that approaches fantasy rather than plausible technology. The energy systems required for billion-year operation while maintaining perfect electromagnetic silence would demand engineering solutions that remain beyond theoretical possibility, even for advanced civilizations. The risk assessment protocols developed through decades of asteroid and comet tracking provide comprehensive frameworks for evaluating potential threats from cosmic objects. These protocols account for gravitational perturbations, outgassing effects, and trajectory uncertainties while maintaining conservative safety margins that protect against calculation errors or unexpected phenomena. 3I/Atlas falls well within established safety categories regardless of potential artificial characteristics. The international coordination that has characterized 3I/Atlas observation demonstrates the effectiveness of existing institutions for handling unprecedented astronomical discoveries. The rapid information sharing, coordinated observation campaigns, and transparent data analysis that marked this investigation provide confidence that genuinely anomalous objects would receive appropriate attention and analysis through established scientific networks. The speculative scenarios we've explored throughout this investigation serve valuable purposes for expanding imaginative thinking about cosmic possibilities while highlighting the importance of evidence-based reasoning for distinguishing between plausible hypotheses and unfounded speculation. The exercise of considering exotic possibilities forces more rigorous analysis of actual observations while revealing assumptions that might otherwise remain unexamined. The philosophical value of confronting cosmic uncertainty through systematic investigation rather than fearful speculation provides lessons that extend beyond astronomical observation to general approaches for handling unknown phenomena. The scientific method demonstrates how systematic observation, collaborative analysis, and evidence-based reasoning can resolve apparently mysterious circumstances while expanding understanding of natural processes. The educational impact of 3i/Atlas extends beyond its immediate scientific results to demonstrate how modern astronomy operates as a collaborative, transparent, international enterprise capable of studying unprecedented phenomena while maintaining appropriate skepticism about extraordinary claims. The investigation provides a model for how human institutions can coordinate effective responses to cosmic challenges while preserving both scientific rigor and public trust. The reassuring conclusion that emerges from comprehensive analysis of 3i/Atlas confirms that this ancient wanderer poses no threat to human civilization while providing valuable scientific insights about interstellar objects and galactic evolution. The mathematical certainty of its safe passage through our solar system, combined with observational evidence supporting natural origin, demonstrates that cosmic visitors need not be feared when approached through systematic scientific investigation. The broader implications for cosmic awareness suggest that the universe contains abundant natural phenomena sufficiently strange and remarkable to satisfy human curiosity about cosmic mysteries without requiring artificial intelligence or exotic technology. The real cosmos, revealed through patient observation, proves more wonderful and surprising than most speculative scenarios, while operating according to natural laws that provide both comprehensible explanations and reliable predictions about future behavior. The journey through increasingly speculative scenarios surrounding 3i/Atlas reveals something profound about human psychology and our relationship with cosmic uncertainty. While mathematical analysis confirms this ancient wanderer's harmless passage through our solar system, our willingness to imagine exotic possibilities speaks to deeper needs for meaning, significance, and connection within a universe that often seems indifferent to human existence. The exercise of exploring what might be teaches us as much about ourselves as about the cosmos we're attempting to understand. The speculation itself serves essential functions beyond entertainment or intellectual exercise. By pushing our imaginations toward extreme possibilities, we better appreciate both the genuine mysteries that surround us and the constraints that evidence places on reasonable explanation. The scenarios we've explored force recognition of how much we don't know about consciousness, intelligence, and technological possibility, while highlighting the importance of evidence-based reasoning for distinguishing between plausible hypotheses and unfounded fantasy. The psychological comfort that many people derive from believing in alien visitation reflects legitimate needs for cosmic significance that remain inadequately addressed by conventional scientific education. The universe described by modern astronomy, with its vast scales and apparent emptiness, can seem hostile to human meaning and purpose. Speculation about alien intelligence provides emotional satisfaction by suggesting that consciousness like ours exists elsewhere, that we're part of larger cosmic communities, and that our technological development serves purposes beyond mere survival. Yet the real universe revealed through careful scientific observation proves more remarkable than most speculative scenarios, while operating according to principles that remain accessible to human understanding. The natural processes that created 3i/Atlas accelerated it to tremendous velocities through gravitational encounters and carried it across billions of years of interstellar wandering, demonstrate cosmic creativity that exceeds human imagination while remaining comprehensible through mathematical analysis and observational study. The educational value of cosmic speculation lies not in its probability, but in its capacity to expand conceptual horizons, while highlighting the methods that distinguish between possible and actual. Students who learn to evaluate extraordinary claims about alien visitation develop critical thinking skills that prove valuable for analyzing all forms of unusual assertions, from political propaganda to commercial advertising. The intellectual discipline required for separating evidence from speculation serves society far beyond astronomical applications. The media literacy implications of our speculative journey become increasingly important as information technology enables rapid propagation of both scientific knowledge and unfounded conspiracy theories. The challenge of distinguishing between legitimate scientific uncertainty and baseless speculation requires analytical capabilities that formal education systems often fail to develop adequately. Learning to evaluate claims about cosmic phenomena provides practice for evaluating all forms of information in our increasingly complex media environment. The international cooperation that characterized 3I/ABELAS observation demonstrates humanity's capacity for coordinated response to cosmic challenges. When institutional frameworks exist for productive collaboration, the rapid information sharing, transparent data analysis, and coordinated observation campaigns that marked this investigation suggest reasons for optimism about our species' ability to handle even more extraordinary discoveries through existing scientific networks and diplomatic institutions. The technological progress that enabled comprehensive study of 3I/ABELAS within months of its discovery reflects remarkable advances in astronomical capability that continue accelerating at unprecedented rates. The combination of automated sky surveys, space-based telescopes, and global coordination networks provides humanity with cosmic awareness capabilities that would have seemed fantastical just decades ago. Our growing technological sophistication increases the probability that genuinely anomalous phenomena would be detected and analyzed effectively. The philosophical frameworks required for living with cosmic uncertainty involve accepting that significant questions about our place in the universe may remain unanswered for extended periods, while maintaining curiosity and analytical rigor for approaching whatever mysteries we encounter. The intellectual humility required for acknowledging the limitations of current knowledge must be balanced with confidence in human capability for expanding understanding through systematic investigation and collaborative analysis. The existential implications of cosmic awareness force recognition that human civilization exists within contexts that exceed our complete comprehension while operating according to natural laws that remain accessible to scientific investigation. Whether or not alien intelligence exists elsewhere in the galaxy, humans must develop cosmic perspective that enables productive engagement with phenomena that transcend terrestrial experience while maintaining social cohesion and individual psychological health. The spiritual dimensions of cosmic awareness need not conflict with scientific rationality when approached through frameworks that distinguish between evidence-based knowledge and personal meaning-making systems. Many people derive profound spiritual satisfaction from contemplating cosmic scales, natural complexity, and the remarkable processes that enabled consciousness to emerge within the universe. Such spiritual responses can coexist productively with scientific skepticism about extraordinary claims lacking adequate evidence. The preparation requirements for handling future cosmic discoveries involve developing institutional capabilities, educational frameworks, and psychological readiness for encounters with phenomena that might exceed current understanding while maintaining analytical standards that prevent premature acceptance of extraordinary claims. The balance between openness to possibility and commitment to evidence represents one of the most important intellectual challenges facing human civilization. The legacy considerations that arise from our investigation of 3I/ABELAS involve questions about how human civilization should approach cosmic awareness as our technological capabilities continue expanding toward interstellar exploration. The methods we develop for studying potential alien phenomena, the institutional frameworks we create for international coordination, and the educational approaches we use for developing cosmic perspective will influence how our species handles whatever genuine mysteries await us in the decades and centuries ahead. The optimistic conclusion that emerges from our speculative journey suggests that human curiosity, analytical capability, and institutional cooperation provide adequate foundations for approaching whatever cosmic discoveries might transform our understanding of our place in the universe. While we cannot predict what forms such discoveries might take, the combination of scientific method, international collaboration, and intellectual humility that characterized 3I/A/TELES investigation offers reason for confidence in our species' capacity for productive engagement with cosmic uncertainty. The continuing mystery that surrounds consciousness, intelligence, and their possible manifestation throughout the universe ensures that speculation about alien phenomena will remain relevant regardless of what future discoveries reveal about specific objects like 3I/A/TELES. The questions we've explored about recognition, communication, and coexistence with non-human intelligence represent permanent challenges for any technological civilization, worthy of continued consideration even when current evidence supports mundane, rather than exotic explanations. The invitation that cosmic awareness extends to human consciousness involves embracing wonder about natural processes that created conditions enabling our existence while maintaining analytical discipline that distinguishes between what we can observe and what we can only imagine. The universe proves sufficiently strange and remarkable through natural phenomena alone to satisfy human needs for cosmic significance, while providing endless opportunities for discovery, learning, and expanding appreciation of the processes that connect our consciousness to cosmic evolution across deep time. As 3I/ATLAS continues its ancient trajectory toward the outer solar system, carrying with it the accumulated momentum of billions of years of galactic wandering, we bid farewell to our first extensively studied visitor from alien stellar neighborhoods. The months of observation, analysis, and speculation that accompanied its passage through our cosmic vicinity have provided more than scientific data about interstellar objects. They have offered a mirror in which we can examine our own assumptions, fears, and aspirations as we take our first tentative steps toward genuine cosmic awareness. The departing object leaves behind a legacy that extends far beyond its unusual chemistry or remarkable velocity. 3I/ATLAS has demonstrated how modern human civilization responds to unprecedented phenomena, how our institutions coordinate international scientific collaboration, and how we balance rational analysis with imaginative speculation when confronted with cosmic mysteries. The investigation has revealed both our capabilities and our limitations as we attempt to understand our place within galactic contexts that dwarf terrestrial experience. The scientific harvest from this ancient wanderer will continue yielding insights long after the object itself fades beyond telescopic reach. The spectroscopic signatures that initially puzzled astronomers have expanded our understanding of chemical diversity among interstellar objects, confirming that formation conditions around alien stars produce volatile ratios unknown within our solar system. Future theoretical models of planetary formation must account for the chemical environments that created 3I/ATLAS's distinctive carbon dioxide dominance. The observational techniques refined during 3I/ATLAS study have advanced human capability for characterizing fast-moving interstellar visitors during brief observation windows. The coordination between space-based telescopes, ground-based observatories, and automated detection systems has created protocols that will prove valuable for studying the dozens of similar objects that next-generation surveys will discover over the coming decade. The international cooperation that characterized 3I/ATLAS investigation provides a template for how human institutions can coordinate responses to cosmic phenomena that exceed national boundaries and individual capabilities. The transparent data sharing, rapid communication protocols, and collaborative analysis that marked this investigation demonstrate our species' capacity for productive cooperation when facing challenges that transcend terrestrial politics and competition. The speculative framework that we developed for exploring extreme possibilities has revealed the importance of maintaining clear boundaries between imaginative hypothesis and evidence-based conclusion, while acknowledging that the universe may contain phenomena that exceed current theoretical understanding. The intellectual discipline required for such distinction serves human civilization well beyond astronomical applications, providing analytical tools for evaluating extraordinary claims in any domain of human experience. The psychological insights that emerged from our journey through increasingly dramatic scenarios illuminate human needs for cosmic significance and our tendency to project meaning onto natural phenomena that operate according to principles indifferent to human desires. Understanding these psychological dynamics helps us approach future cosmic discoveries with better preparation for managing both individual and social responses to phenomena that challenge comfortable assumptions about our place in the universe. The educational value of the 3I/Atlas investigation extends to demonstrate how scientific knowledge develops through the interplay between careful observation and creative speculation, between individual insight and collaborative verification. Students who follow the progression from initial detection through detailed analysis to confident conclusions about natural origin gain appreciation for the methods that distinguish reliable knowledge from unfounded assertion. The technological implications of comprehensive 3I/ATLS study demonstrate how rapidly advancing astronomical capabilities are transforming human ability to study cosmic phenomena in real time. The detection systems, analysis algorithms, and coordination networks that enabled this investigation represent just the beginning of capabilities that will emerge over the next decades as artificial intelligence, space-based telescopes, and automated surveys revolutionize observational astronomy. The philosophical questions raised by our investigation of potential alien intelligence will remain relevant regardless of what future discoveries reveal about the specific nature of interstellar visitors. How should humanity prepare for eventual contact with non-human intelligence? What frameworks should guide our responses to phenomena that exceed current understanding? How can we maintain both appropriate skepticism and productive openness when confronting cosmic mysteries? The institutional preparedness that developed during 3I/Atlas observation provides foundations for handling even more extraordinary discoveries should they occur as human cosmic awareness continues expanding. The communication protocols, verification procedures, and response frameworks that proved effective for studying this natural comet would serve as starting points for addressing genuinely anomalous phenomena that might challenge current scientific paradigms. The future vigilance that 3I/ATLS investigation encourages involves maintaining systematic observation of cosmic phenomena while developing analytical capabilities for recognizing truly unprecedented events should they occur within our expanding observational reach. The balance between expecting natural explanations and remaining alert for genuine anomalies represents one of the most important intellectual challenges facing astronomical research in the coming decades. The Vera Rubin Observatory's upcoming Sky Survey promises to transform interstellar object studies from rare curiosities into routine astronomical phenomena, detecting objects like 3I/ATLS at rates of several per year, and providing statistical samples large enough to test theoretical predictions about their origins, compositions, and trajectories. This observational revolution will either confirm that such visitors follow natural distributions or reveal anomalies that demand more exotic explanations. The technological trajectory that brought human civilization to the point where we can study ancient interstellar wanderers in exquisite detail continues accelerating toward capabilities that would have seemed fantastical just decades ago. Our growing astronomical sophistication increases confidence that genuinely anomalous phenomena would be recognized, analyzed, and understood through existing scientific networks and analytical methods. The cosmic perspective that emerges from studying objects like 3I/Atlas provides context for human existence that transcends terrestrial concerns while connecting our consciousness to processes that operate across galactic distances and geological time. Such perspective offers both humility about our current limitations and inspiration about our potential for continued growth in understanding and capability. The farewell ritual that accompanies 3I/Atlas's departure into interstellar space involves recognition that this ancient wanderer represents just one example of countless objects that fill the space between stars, each carrying chemical signatures from alien stellar environments and information about galactic evolution that occurred long before our solar system achieved its current configuration. We are privileged witnesses to cosmic processes that connect our local experience to universal phenomena. The gratitude that human civilization owes to 3I/Atlas extends beyond its scientific contributions to encompass the opportunity it provided for examining our own responses to cosmic uncertainty. The object served as a test case for how we handle unprecedented phenomena, how we balance speculation with evidence, and how we maintain both individual curiosity and collective rationality when confronting mysteries that challenge established understanding. The continuing journey that carries 3I/Atlas back into the cosmic dark will span millions of additional years as it travels towards stellar destinations we can only guess at. The object that briefly illuminated our understanding of interstellar chemistry will fade from human observation while continuing its ancient odyssey through galactic space, perhaps eventually encountering other stellar systems where different forms of consciousness might study its passage with curiosity similar to our own. The enduring questions that 3I/Atlas leaves in its wake ensure that human engagement with cosmic mysteries will continue expanding as our observational capabilities and theoretical understanding develop over the coming decades and centuries. Whether future discoveries reveal natural phenomena more remarkable than current theories predict, or genuinely artificial signatures that confirm our cosmic companionship, the analytical methods and collaborative frameworks developed through 3I/Atlas investigation will serve as foundations for whatever cosmic revelations await human consciousness in its continuing exploration of the universe that gave us birth. Safe travels, ancient wanderer, and thank you for the brief window you provided into the deep history and vast complexity of our galactic neighborhood.